Hello, this is Andrew. In this video, I'm going to be talking about space elevators. What is a space elevator? A space elevator would be composed of four main parts. First, a base would sit on the ground or in the ocean, sort of as the headquarters of the space elevator. Secondly, a long cable would reach all the way into space. This cable would be attached to a space station in geostationary orbit. I'd better pause and briefly explain what geostationary is. Geostationary, also known as GEO, is an altitude at which an object orbits at the same speed that the Earth rotates. This means that an object in geostationary orbit would appear to be floating motionless in the sky, if you could see an object 22,000 miles away, of course. Anyway, the third part needed to make a space elevator work is a heavy counterweight orbiting at beyond GEO. The cable would extend past GEO to attach to this heavy counterweight. By orbiting beyond GEO, the counterweight would have excess orbital velocity and would tug outwards, keeping tension on the cable. To prevent the ground base from being lifted into the sky by this tension, the base would need to be heavy. The fourth and last part of a space elevator would be the climbers that ascend and descend the cables. They would take people and cargo up and down from space. That's the most common depiction of a space elevator. The main problem with this design is that the cable would need to be extremely long to reach up to GEO. In fact, long enough to circle the entire Earth. A cable that long would need to withstand extreme tensions and not break, and yet still be light and affordable, with the strongest tubes yet made being able to withstand 17.5 million pounds of pressure per square inch. Carbon nanotubes might be up to the task. It's been calculated that a space elevator's cable would need to withstand 19 million pounds of pressure per square inch in order to be safe, so we're pretty close. The main problem is that the longest carbon nanotubes yet made are only inches long. Theoretically, carbon nanotubes could be made over 6,000 miles long without breaking, but for a space elevator, they'd need to be made over 23,000 miles long. Also, did I mention that the cost of creating a cable that long would be huge? There are alternative ideas that propose building an elevator that only extends up to low Earth orbit instead of GEO. However, these designs require entire rings orbiting the Earth or other extreme measures that seem to cause more problems than they solve. Even if a space elevator could theoretically work, it still may not work in reality. One problem could be that a cable that long could easily start wobbling and get out of control. Solar flares would be a real concern for the cable, since radiation actually pushes everything it touches. Small thrusters could be mounted on the cable to keep it stable, but they would be a pain to maintain. The climbers would also have to avoid bumping into the thrusters while traversing the cable. It turns out that the climbers themselves, could cause a lot of wobbles as well, since they will be traveling at less than orbital velocities at lower altitudes on the cable. This could be solved by ascending the cable over a period of perhaps 1 month, but that's just a bit too slow to be practical. Then there's the issue of space junk, which would be orbiting at high relative velocities to the cable. The cable would also be vulnerable to terrorist attacks. It wouldn't take much to destroy the cable, so lots of expensive security measures would need to be taken. What about space radiation? If people were taken up on the elevator, they'd be passing through Earth's radiation belts. In low Earth orbit, astronauts are protected by Earth's magnetic field, but in geostationary, people would be exposed to large amounts of solar radiation. In short, it appears we've got a ways to go before a space elevator could ever become a reality. Still, another technology is making lots of progress: single stage to orbit aircraft. There's a lot of competition going on from different companies who are trying to be the first to develop a working spaceplane. Once spaceplanes become a reality, it will be possible for rich people to buy tickets to enjoy zero-G and spectacular Earth views for several hours and maybe even board the International Space Station for a while. As more single-staged orbit aircrafts are developed, the cost to fly one will come down until someday maybe ordinary people like you and me will have access to space. Please subscribe if you enjoyed the video, and thanks for watching.